So the first concept we looked at was area between a curve and the x-axis. And now we're going to look at the area between two curves. And it's actually easier. In fact, you do not have to worry about parts of it being above the x-axis or below the x-axis. All the negatives and positives will work themselves out, that the area between two curves is just take the upper curve, subtract the lower curve, and you'll find the area. So here, if we look at this picture, 2x squared plus 2 and negative x squared plus 2x plus 10. There's our two curves. And very cool that we can now find that area bounded between the two of them. Okay? Technically, what you're doing when you're subtracting is you're finding the area under the red one all the way down to the x-axis, and then subtracting the area under the blue one all the way down to the x-axis, giving you what's in between. But the beautiful thing about this is now it doesn't matter if part of it's above the x-axis and part of it's below. All of that will work itself out and give you the exact area. So step one, we have to do a sketch, and we need to find this point and this point. How do we do that? Well, we set the two equations equal to each other and solve. We get x equals plus or minus 2. So the one that opens up is the positive x squared, and the negative one opens down. Yeah, positive one will open up, negative one opens down. So I can label these points on here. This one's at negative 2, 2, and this one is at 2, 10. Once you found the intersection points, then you can find the area just by subtracting the two functions. So negative 2 to 2 of the upper function minus the lower function. And usually, we can look at the two equations and do a bunch of simplification inside the brackets first to make our integration simpler. So for example, in this case, the inside simplifies to just negative 2x squared plus 8. And that's not a hard integral to do. Can I scroll down to here? Is that okay? And we get 64 over 3 as the area. All right, let's look at the second one. Again, we draw a picture. X squared minus 2x minus 3 and y equals x plus 1. So the parabola is opening up. So the line will be the function on top, and the parabola would be the function on the bottom. First thing we have to find out is, where does it intersect? And we would get this point at 1, 0. Sorry, at negative 1, 0, and this point at 4, 5. So we set up our integral, and it's always the upper one subtract the lower one. If you accidentally do the lower one subtract the upper one, you will get the same answer, but negative. So instead of erasing everything, I just say oops, and go back and put absolute value bars around everything instead of rewriting all your work. You, in most situations, you know something about the graph. So you have some skills in graphing. In this one, a parabola and a line, right? Sometimes you wouldn't, right? So in that case, I would just do the question. And since area can't be negative, it is negative. You put the wrong one on top. And it's just a matter of doing the absolute value after that.
Is that an accepted thing? Like, if you put in the absolute value bars because you accidentally messed up the original thing?
I would just write, oops, I put the wrong one on top, and then put, I just did the absolute value of everything. That would be perfectly fine. Because for me, it would not be very efficient to just erase everything and redo all the work just to get the same answer with a different sign. So now when we simplify, the integral is not hard to do. And again, I didn't even show the work here for plugging it in. 125 over 6 is the area. Do you want to try the next one on your own? I'll put up the answer in a bit. Do you need to see the question? Yeah. I'll put up the answer to see.
See, when I did my integral, I forgot to actually do it.
32/3. Here, I'll go view, zoom, entire page.
The square bracket forgot actually doing the integral.
Graphing y equals x squared plus x minus 2, I would probably find my x-intercepts. X plus 2, x minus 1, x equals -2, x equals 1, and then draw a parabola going up through them. If you wanted to find the exact vertex, it would be halfway in between, so -0.5 comma something. And you could plug in that -0.5 and actually calculate it if you wanted to find the actual vertex. So that's probably what I would use to graph that parabola in that case. Of course, you could always use calculus, right? You could take the derivative, find your minimum point that way as well. Okay, last one we'll do together. View, zoom, page width. And it's not, we'll do it without a calculator. It's not actually, I think, that bad without a calculator. The volumes of revolution, that'll be tomorrow. So, f of x, if you wanted to draw a quick graph of f of x, notice you could factor out an x squared. And you would have x-intercepts at 0 and at -2. It's a positive x cubed graph, so I know it starts down here. Wow. I've got one hole to draw through, and or one point. And it's going to bounce off here and go up. So that's just graphing using grade 12 pre-calculus with multiplicity of 2, so that one x-intercept's going to bounce, and the end behavior of an x cubed graph. For the second graph, g of x, you can factor that one as well. Wow, it's not what I wanted to do. Wow, it's still not what I wanted to do. Yeah, this is what I wanted to do. Ooh, I wanted, let's go purple. I'm going to draw that one in purple. So I have 0 and -2, and I know that my parabola is opening up. So my parabola is looking like this. Okay. Now, my blue graph will go up sharper because it is a cubic than my purple graph. It's not a really good drawing at that point. But when we solve these two equations, in other words, when I try to find out where they intersect, okay? If I make x squared or x cubed plus 2x squared equal to x squared plus 2x, and I solve this, I would move everything over to one side. And I'd factor this, factor out an x, leaving me with x squared plus x minus 2. and this will be x plus 2, x minus 1. So we got x equals 0, which we already knew, x equals minus 2, which we already knew, and x equals 1, which my graph is apparently not drawn very well. I'm going to fix this up on this side just to make it prettier. Apparently this blue part sharply goes up, and the purple one not so much. So we have these points. They intersect at -2, 0, 0, 0, and then here at 1, 3. And the area we want to find, which I will color in nicely with whatever color this appears to be, is here and also there. But we can't just do the integral from -2 to 1. Because can you see that between -2 and 0, the blue graph is the top graph? But between 0 and 1, the purple graph is the top graph. So when we're doing this integral, and when we set it up, here, I'll do it off to the side here. We want to find the integral from -2 to 0. And first of all, we'll take f of x and we'll subtract g of x. Then we'll do the integral from 0 to 1, and this time we'll do g of x subtract f of x. So this will become the integral from -2 to 0. F of x is x cubed plus 2x. If I minus the other one, I'll get x cubed plus x squared minus 2x dx plus the integral from 0 to 1. If you subtract them the other way, it will be negative x cubed. Well, I'll just do negative x cubed minus x squared plus 2x dx. Just double check my math when I subtracted them. Yeah, perfect. So what makes this one longer is that you're just having to figure out two different parts. So now we're going to have to figure out those parts. We've got x to the 4 over 4 plus x cubed over 3 minus x squared from -2 to 0 plus, and then this one will be minus x to the 4 over 4 minus x cubed over 3 plus x squared from 0 to 1. Doing that one in blue, plus, I'm going to do this one in green. Do you know why I made some brackets bigger and some are smaller? Yeah, plugging in 0, this is like happy math days. Mental math heaven. Calculations where you plug in 0 and everything's 0. Then plugging in -2. This will be 16 over 4, which will be 4. plus a negative 8 divided by 3 minus negative 2 squared will be 4. Oh, this is nice. Those cancel out too. And in the green one, okay, the easy mental math is when you plug in the 0. And the not too crazy mental math is when you plug in the 1. So you would get negative 1/4 minus 1/3 plus 1. So in the end, the first section, its area becomes 8/3. And the green section, if you get a common denominator there of 12, you got negative 3/12, negative 7/12 plus 5. Units squared. Don't worry about the calculator part. So you could also do this on your calculator to find the areas if you want. We're not going to worry about that right now. We did it without our calculators. So it actually, without a calculator, it's not that bad. So every time you're finding area between curves, you're going to have to find out where they intersect. This one intersected at 3 points, so then you have to be aware which function is on top, which one is on bottom. You have to find each of those sections separately.